Good morning, girls. We want to see addition principle today. Yesterday we saw what is cardinality of the set. Now using the cardinality, using the concepts of disjoint sets, we will prove the addition principle. Okay. So I think yesterday we had written the statement of the theorem. I'm rewriting it. Let A and B be two disjoint and finite sets. Let cardinality of A be equal to n and cardinality of B is equal to m. Then cardinality of A plus cardinality of B is equal to n plus m. Okay, so here we have to understand the sets are disjoint. Disjoint sets means what do you mean by disjoint sets? Girls, what do you mean by disjoint sets? Do you hear me? So what do you mean by disjoint sets?
The elements in the sets are not equal.
Not equal nahi. There is nothing
They
in
don't have
common.
common element.
There is nothing in common. Not a
Mutually
single.
exclusive.
Their intersection is an empty set. Okay. Now we are given one more thing that they are finite, right? So first we have to think about the cases. What will happen if either of them is an empty set? Then what will happen that we have to see. Okay, so we will start with this possibility. If A is equal to phi, that means if A is an empty set, okay, then what will happen to the union? A union B will be equal to what? There is nothing in A and B is non-empty. So what will be their union? Suppose we have,
B.
it will be B, right? Because see, if A is phi, phi means there is no element, okay, empty set. And B is some set, say A comma B. So what will be A union B? A union B will be simply AB, that is equal to B. All of you are following this? A union B is equal to B. And then what will be the cardinality? Therefore, cardinality, we want to prove cardinality of A union B. Okay, I'm sorry, in the statement I have to write here. Then cardinality of A union B is equal to cardinality of A plus cardinality of B, that is equal to n plus m. This is what we want to actually prove. Okay, this is our aim. Cardinality of A union B is cardinality A plus cardinality B. So here in this case, if A union B is equal to B, then if you take cardinality, it will simply become cardinality of B, which is nothing but M, and M I can write as 0 plus M. And 0 means what? Cardinality of A, because A is an empty set. Do you understand it? Do you understand it?
Yes, ma'am.
Yes.
So this was the first case where we considered that A is phi. See, empty set, finite set. We have to consider these cases. Now, second case I would consider, this is the first case. Second case I would consider if B is an empty set.
Ma'am, excuse me.
Yes.
Can you allow Sanjana in the meeting?
Yeah, I have allowed. Just
Yes,
now I
ma'am.
unlocked the meeting. If B is equal to 5, that is empty set, then what will be A union B?
A.
It will be A then. And what will be A mod of A union B? That is cardinality of A union B will simply become cardinality A, which is N, which I can write as N plus 0, which is cardinality of A plus cardinality of B. So as A is phi, as B is phi here, cardinality of B is equal to 0. And here as A is phi, cardinality of A is 0. Okay. So we have proved this if either of the sets is phi. Okay. So now we will consider the third case where the sets are non-empty. Okay. Finished writing this?
Yes, ma'am.
Let A not equal to phi and B also not equal to phi. Okay. And of course, what else we are considering here? These two are disjoint sets. Okay. A and B are disjoint sets. This we have to write, or this we have to remember always. That is a given fact. Then only this is applicable. So cardinality of A is equal to N and cardinality of B is equal to M is given to you. That means the set A had some N elements, right? Yes?
Yes, ma'am.
And B has M elements, M for Mumbai, N for Nagpur. Okay. So A has N elements. Say A is equal to, I will write as x1, x2, xn. Okay. And B has M elements. Say y1, y2, up to ym, such that no xi is equal to, or I will write such that xi is not equal to yj for all I goes from 1 to up to n and j goes from 1 to up to m. So all xi's and yj's are distinct elements. Okay. Are you getting this? A और B में कुछ कॉमन नहीं है. So no xi is equal to yj. Okay. So see, as I have n elements, I can have a bijective mapping. Okay. As mod A is n, there exists a bijective mapping, one-to-one mapping, say f from A to XM. Okay. And as mod B is equal to M, there exists a bijective mapping See what I am writing now. Carefully see it. Okay, though I am taking names as y1, y2, ym, I am writing this as another mapping G from B to XM only. Okay, though the names of my elements are y1, y2, ym, I am writing xn and xm. Finished writing this? Girls, finished writing this?
Yes, ma'am.
Yes, ma'am.
Now see what I'm going to do. I'm keeping these elements of A as x1, x2, xn, but I will rename the elements of B as xn plus 1, xn plus 2, मतलब आगे के numbers. Because all of them are distinct, so I will rename these numbers x n plus 1, x n plus 2 up to x n plus m. Okay. So we construct a bijective mapping. Bijective means 1 1 on 2, huh? Mapping. Say H from A union B now. Okay. To X n plus M. So for this, we rename the elements of A and B as follows. So I will rename the elements as say xi belongs to A है suppose हमारा is renamed as AI, where I goes from 1 to up to n. Okay. Yes, girls, finish writing. Xi belongs to A is renamed as AI, where I goes from 1 to up to n, and Yj belongs to B is renamed as A I plus 1. Okay, or I will say not I plus 1, I will say this as I plus j, n plus j, sorry, n plus j. Please rewrite this as n plus j. Do you hear me, girls?
Yes, ma'am.
So please write this as n plus j. So what will happen? Whatever n you have from that, and here also j goes from 1 to up to m. Okay, so it will become n plus 1, n plus 2, n plus 3, and so on. Therefore, set A क्या होगा? What will be the set A? We are renaming these elements. Set A के elements क्या होंगे? A1, A2, है ना? हर xi को मैं क्या कहने वाली हूँ? What I am calling every xi? Come on. What I am calling x1 क्या बनेगा? A1 बनेगा ना? Yes or no?
Yes, ma'am.
x1 बनेगा A1, x2 बनेगा A2, एंड सो ऑन. xn क्या बनेगा? an बनेगा. एंड बी सेट क्या होगा अभी बताओ? व्हाट विल बी द बी सेट?
A and N.
आपका n वैसे ही रहेगा, चेंज क्या होने वाला है? j.
J.
So j will change from 1. So a n plus 1, a n plus 2, a n plus 3, and so on. कहाँ तक जाएंगे हम? a n plus m तक जाएंगे, right? And as A intersection B is phi, A and B have distinct elements, right? And therefore, what will be A union B? What will be A union B?
A2
A1,
up to N.
A2 up to AN, comma, AN plus 1, AN plus 2 up to AN plus M. And all these elements are distinct. So what will be the cardinality of A union B? What is cardinality of A union B? How many elements A union B contains? कितने total elements दिख रहे हैं आपको? How many total elements? Can you see n plus m elements?
Yes, ma'am.
हाँ.
Yes, ma'am.
So cardinality of A union B becomes n plus m, and that is nothing but cardinality of A plus cardinality of B. Okay. So we have to give this mathematical proof. We have to put our arguments. Okay. When we take example, it becomes very easy. Or you can say by default, ma'am, it has to be like this. But you have to actually give a mathematical proof for the same. Yes, tell me as you finish.
Done, ma'am.
Hmm. Okay. Okay. See, for example, if I take set A as MILE, mile, okay, and set B as uh, sort. Okay, so what do you find here? A intersection B is 5, right? Cardinality of A is 4. Cardinality of B is also 4 here. What is A union B then? What is the set A union B?
MILE
MILESORT. So you can see that cardinality of A union B becomes 8. So first to second, third, fourth, fifth, sixth, seventh, eighth element we have. So that is nothing but 4 plus 4, that is equal to cardinality of A plus cardinality of B. So when we consider example, the idea is here. Now for example, और एक मैं एग्जाम्पल लेती हूँ, कहाँ पे हम एडिशन प्रिंसिपल यूज कर सकते हैं, वेयर वी कैन अप्लाई एडिशन प्रिंसिपल. How many ways are there? This is called as sum rule also, okay? How many ways are there to select a card from a deck of 52 cards, which is either a face card or a number card? So whenever you have the word or, you have to understand that you have to use addition principle, but you have to first check whether your events or sets are disjoint. If they are disjoint, then only you will go directly for addition principle. If the sets are not disjoint, then you cannot apply uh, addition principle, even though there is or. Are you getting me?
Yes,
So tell me, how many ways are there to select a card from a deck of 52 cards, which is either a face card or a number card? Very simple example I am giving you. So you are selecting something. You have done permutations and combinations, right? Whenever you get the word select, okay, what do you use for the word select?
Commutation.
Combination.
combination.
Permutations are used when you are arranging something. Those are permutations. Okay. Combinations means selections. Please remember these words always. Arrangement means permutations. Selection means combinations. So combination NCR. What do you mean by NCR? We are going to study this also. No, what is NCR?
N factorial upon R factorial
You know the
n
formula,
minus R factorial.
but what do you mean by that? What is the meaning of NCR symbol? What is the meaning of NCR? It is selection of R objects, right? From N objects, correct? और सिलेक्शन ऑफ एन ऑब्जेक्ट्स टेकन आर एट अ टाइम ऐसे भी कहा जाता है. सिलेक्शन ऑफ एन ऑब्जेक्ट्स टेकन आर एट अ टाइम. सो यहाँ पे आपको कितने ऑब्जेक्ट सिलेक्ट करने हैं? हाउ मेनी कार्ड्स यू हैव? You have 52 cards, right? N is 52. And what is R here? How many cards you want to select? Select a card.
One.
Means only one card you have to select, which is either a face card or a number card. ऐसे मैं कह रही हूँ. I can reframe this question in any way. Okay, I can say which contains an even number or an odd number. ऐसे भी कह सकती हूँ मैं. Okay, so those are also. So first of all, tell me a face card and a number card. Are they disjoint sets? Do you have any card which contains number also on it and face also?
No.
No. That means there is nothing in common, right? A face
Yes.
card is never a number card. Number card is never a face card, right? ऐसा कार्ड आपके पैक में होता है क्या जिसपे नंबर भी है और फेस भी है? नहीं होता है. सो ये दोनों डिसजॉइंट इवेंट्स है. हाउ मेनी फेस कार्ड्स आर देयर इन द कार्ड्स?
12 face card.
12 फेस कार्ड्स, राइट? सो 12 में से एक चूज करना है. सो दैट कैन बी डन इन टोटल कार्ड्स 52 है हमारे यहाँ पे. मैं ये कर देती हूँ. पहला जो है मेरा पहला इवेंट, इसमें मैं n इज इक्वल टू 12 लूंगी. देर आर 12 फेस कार्ड्स. ओके, सो 12 में से मुझे एक चूज करना है. दैट कैन बी डन इन हाउ मेनी वेज? 12 C1 ways. Everybody is getting this?
Yes, ma'am.
I have 12 face cards and I am choosing one of them, so that can be done in 12 C1 ways. अभी क्या कहा गया है? अभी नेक्स्ट वर्ड क्या है आपके पास? इट इज और. ये दोनों डिसजॉइंट इवेंट्स है आपके. तो ये आपका मॉड ए आ गया. अभी मॉड बी आपको ढूंढना है. बी इज व्हाट? हियर ए आई एम सिलेक्टिंग फेस कार्ड. सिलेक्ट फेस कार्ड, ये मेरा इवेंट है, यह मेरा सेट है. बी क्या है? सिलेक्ट अ नंबर कार्ड. तो देर आर 4 सूट्स: क्लब, स्पेड, हार्ट एंड डायमंड. ओके, and every suit contains how many number cards? 1 to 10. 1 to 10. And there are 4 suits, so there are 40 number cards, and you are selecting again one. So that can be done in how many ways? Mod b is equal to 40 C1 ways. Correct? Yes. Have you understood this? I want to
Yes,
go to
ma'am.
the next page. So mod A is equal to 12 C1 and mod B is equal to 40 C1. ए एंड बी आर डिसजॉइंट, ये आपके मन को अपील हुआ है क्या? आर यू कन्विंस्ड फॉर इट? So mod A union B will be what? 12C1 plus, that is mod A plus mod B. Okay, so 12C1 NC1 is equal to N होता है. एक एलिमेंट सिलेक्ट करना है, so आंसर इज 52. So obviously आप 52 कार्ड्स में से एक चूज कर रहे हो ना, आप जब डिसजॉइंट इवेंट्स कर रहे हो तो. Are you getting it?
Yes.
Yes, ma'am.
अभी आप एक ऐसा ही मुझे करके दिखाओ. Bear with me, girls. I cannot hold these outside noises. Okay. How many ways are there to select a card from 52 cards? Such that contains either a red card or a black. I'm taking very simple examples. Okay. So आप orally मुझे बता सकते हो क्या आंसर आएगा? How many red cards are there and how many black cards are there?
6 red cards.
26 red cards, right? And 26 black cards.
Black cards.
So is there anything common? Is there a card which is red also and black also?
No.
No.
No. So these are disjoint events. So 26 plus 26, आपका आंसर वापस
52.
52. समझा? This is how one can use addition principle. You have to first understand that there is nothing in common. Okay? Suppose एक और एग्जांपल मैं आपको दे दूं कि
Ma'am, we were writing question.
बस 8:48 हो गया है. हाँ, मुझे अटेंडेंस लेना है.
Done.
मैं आगे का एक क्वेश्चन आपको दे रही हूँ होमवर्क के लिए. एक सेट ले लो. एक एलिमेंट हटा देती हूँ यहाँ से. टेक इट 1 to 9. Make it 1 to 9. So how many numbers are divisible by 2 or 5? Huh?
Okay, ma'am. Ma'am, can you show first 2 slides? 1 minute.
This one?
And first one also. Now second slide. Ma'am, second slide.
Yes, wait.